All right, hello, hello. Let me see if I can figure out how to use this. Okay. It's working, cool. All right, hello everyone. My name is Josh Lehman. I lead the Urbit Foundation. And I'm here to talk to you today about what Urbit does, what it can do for you, what it has to do with Web3 in general. And so here's a little overview of what I'm going to be talking about, just to give you a high-level rundown. We'll talk about what it is, the perennial question, why you should care, and do a little bit of Urbit by example, show you what people are actually using it to build things with. It's a lot easier than digging through each technical detail. And then we'll give a little glance at the ecosystem. And so with that, let me dig in. All right. So I'm guessing many of you are probably familiar with Urbit. That's why you're here. You've maybe heard of it. You might be wondering what it is. I have no idea why that would be. Urbit has a bit of a reputation of being hard to understand. That might be because it's a technology stack that is pretty novel. Right? This is literally what it is. It's a functional assembly language called Nock. It's a statically typed systems language called Hoon. It's a deterministic operating system called Arvo, a virtual machine called Ver, and a PKI built on Azimuth for public key infrastructure called Ethereum. Sorry, called Azimuth, built on Ethereum. It's been under development for about a decade, which is a little bit of time. But this isn't the angle I want to go down for explaining what Urbit is. We're going to go take a different tack. This is probably the best way to understand it. Okay? Urbit is a new operating system for powering personal servers. And I want to break that down a little bit, define these terms. We define them a little differently. So a personal server is an always-on computer, hence the server. It runs your software, it stores your data, keeps it secure, keeps it private, or at least as private as you want it to be. Okay? It should be accessible from anywhere, hence the server again. And it should just stay running and keep working for as long as you keep it running. Okay. Personal servers are not a thing. We do not have these today. Like not even email servers. Right? We should have email servers. Turns out email is even too hard for people to run these days. Right? What we have instead are services. And I want to keep this kind of focused on Web3, but to illustrate the point that Web3 relies totally on services that are not owned by the people that use them. Telegram are other people's servers. Signal, other people's servers. Discord, okay, they call them servers. They're not servers, not in the sense that they explain them to be. Okay, Uniswap, also other people's servers serving a front end. Okay, Twitter is now Elon servers. None of these things are yours. Okay. Now this affects Web3. This is not just some isolated thing to Web2 where Facebook mines your data, right? It's not just purely to Discord. Tornado Cash got shut down from Alchemy, from Infura, right? As long as you're relying on services, you're basically owned. Okay, these are not hypothetical issues. As we like to say, not your keys, not your computer. That kind of makes it easy to understand. And I think it's important to kind of go over why are things like this? Okay, I like to go back to the rationale for this. It's long seated. It's fairly simple. Servers are too complicated. We cannot understand them. Right? If you cannot understand them, you cannot run them, you cannot own them. Okay. A little bit of history. These are some famous characters. Invented Unix, sitting in front of a PDP-11, which is a mainframe. Right? A mainframe is what Unix was designed to run on, and the backbone of the internet is based on Unix. Okay, it should be no wonder that all the things that we use today are just mainframes again. Right? We can access them now from anywhere globally, right? From our pocket, from our desktop, talking to something that could be anywhere in the world. But nonetheless, they're other people's. We are just clients that access servers that belong to other people because we have to delegate the ability to run them to people that are experts at running them because they are so complicated. Okay, that's not a good situation to be in. Right? This kind of underscores the problem pretty well, I think, visually. This is usually used in a different context about the thing that falls apart because some guy has forgot to do something. Now there's a security bug and the whole internet is sort of screwed. But this underscores the complexity of the internet stack. It's just towers and towers and towers and towers of things built on top of technology that dates back to the 1970s and before. Okay, this technology was not built for the kinds of things that we are doing with it today. So if you want to have a personal server, if you want to actually be able to own your data, run your own software, have a chance at understanding it and knowing how all this stuff works, it needs a refactor. And that's what Urbit is. It's like we went back to the 1970s, we threw everything out, started over from scratch, and rebuilt it all. Right? And that's why Urbit's, about 20 years in. Okay, that was a little bit of a rabbit hole. Popping back up, Urbit is a new operating system for powering personal servers. We just talked about personal servers. What's an operating system? Now, if you go to Wikipedia, you're going to get a slightly different definition that's not going to fit on the slide. But this is a good way to think about it. Right? It's a unified set of interfaces to lower-level computing primitives. Right? It's unified, as in you've got a series of things you can do that are all designed to work together. It makes it nice for a developer to use and build with. Okay? What Urbit provides is cryptographic identity, P2P networking, persistent storage, right? An application model for taking advantage of all these things, right? At an OS level. Okay, there's a little more, but this will kind of get the point across, and we'll focus on these things. Okay, so what can you do with this? Like, why would you want to have these things in an OS? Right? Here's a mouthful. Right? So Urbit applications are self-hosted on a node. We call them ships. Right? They're distributed peer-to-peer. I build an application, I publish it, you get it directly from me. Right? They communicate with other applications over that same peer-to-peer network. You might see a theme. All of those packets are signed by the identity that you plug into the ship when you start it up. Okay? That's you, how you sign everything as long as you use an Urbit. All that application data that powers all the software you run on an Urbit is stored there, self-hosted on your server, and it's shared just with the people that you want it to be shared with. Okay. Now this last point is kind of cool. You can take that entire computer that runs all this software, you can compress it into a single file, you can move it to any other machine, boot it back up, and it's exactly the same state as it was before. All your data, all your software, just like it was. Okay. All right. Now I could go through each of these points, a bunch of slides, explain what they all are, show you a bunch of code. I'm not going to do that. It's going to be very long and very boring. Instead, I want to underscore like what you can do with these things, right, when you build real applications. Right? Because there are a bunch of people that are building real applications with this stuff that really underscore all these points. Okay. So, if you boot up an Urbit, chances are you're going to see this. Okay, this is called Landscape, and it's built by a company called Tlon. Right? It's web-based. All these little squares are applications that have a server-side component running on your server, a client that is served by that same server, into usually a web interface. It could be mobile. Could be really any other interface framework, but Landscape focuses on the web because the web is pretty accessible. Okay. You can think about this kind of like Urbit's iPhone 1 moment. This came out in 2020. It looked a lot different then. It's gone through a bunch of iterations. Now, it's pretty simple. It's ultra clean. One of the applications that Tlon builds is called Groups. This is like Discord, but with real servers. You host it. You invite people. When they connect to your server, they have the entire running group data on their server as well, and as you're exchanging messages, you are all staying in sync about what the state of the group is. Right? It's local consensus. Okay. Now, the other thing Landscape lets you do is install software, like I mentioned earlier. All right. This is an application called Pals. It's developed by a guy called PalDev. When you install software, you plug in the developer, you find the application, you install it, you get it directly from them. Right? That's worth double clicking on for a minute. Right? There is no one in between. You're a developer, you publish an app, you install it right from that person. Okay, this is kind of cool. Everyone is their own app store. Okay. Now, another thing to focus on a little bit here, or at least double click on, I guess, is PalDev. What the heck is PalDev? All right, I was introduced as woolref podlex. That probably sounded kind of funny. That's what's called an Urbit ID. You can think about this kind of like a phone number. These are Urbit addresses. When I'm sending packets to another Urbit ship, I'm sending them to one of these Urbit IDs. All right, this is how we resolve names in the Urbit network. It's very much like IP addresses, except a lot easier to speak than 198.1 whatever IP addresses, right? You can also think about them kind of like ENS, if that's more familiar. Now, the thing about an Urbit ID is when you boot a ship, you feed it into the running instance at load, at boot. It gets saved there. Now all packets are signed by the keys of the NFT's owner. Right, I'm not going to dwell too far on this. There's 3 kinds of Urbit IDs you'll probably see. They're called stars, planets, and galaxies. You can look these up, find more information about them on our website. I don't want to focus too much on this because they're all, anyway, there's cooler things to cover. Okay, jumping back to PALs. We installed PALs. This is what it looks like. All those names you see down there, Barter Simsum, Dachas Tibrel, those are all Urbit IDs. Okay. PALs is pretty simple, right? It's a friends list. I request you to be my pal. If you approve it, now we're pals. That's it. That's the entire application. We're done. Okay. The cool thing, though, is that I store all the data about my pals on my ship. Okay. PalDev doesn't have that. It's like a protocol. Every Urbit application you can think of almost as a protocol. I install it, I have the data. Any other application I install can totally just talk to that application without having to get my information from me because I run the software locally. It has access to everything that I store. All right. Now here's an applied example of why that's cool. Totally different developer named Handful Dovned built this thing called Board. The idea is that it's an alternative social media interface that, as if there were no feeds. Instead of a feed, you have a little square, and you can put whatever you want in it so long as it's HTML and CSS, and that's it. And you can change it on the fly. Right? And if you go to the board, you'll just see whatever the present state of everyone's board is, where everyone is your pals. Right? So no 2 Urbit users, unless they have the exact same list of pals, see the same thing here. It's based on who you know. And these 2 developers, they did not collaborate at all. Right? They don't have to exchange information. They're able to bootstrap a social network because PALs exists and people just use that. Okay. Should note also, this is from a specification from this guy named Robin Sloan called Spring 83. There's a link down there if you screenshot and want to check it out. It's pretty cool. This is the first real implementation of it that I know that works, that is actually totally decentralized because every Urbit ship hosts all of this content themselves. All right, moving on. This is Realm. Talking about composability in a permissionless sense, right? Realm is a totally alternative interface to Landscape that's built by a totally different developer that you're going to hear from right after me. Okay, this is a native desktop application that emulates a full-on window manager where every application is an Urbit application. It can run every Landscape application seamlessly, right? Even though it is not Landscape and is built by a totally different group. Realm is pretty cool, right? It's got a window manager just like a traditional desktop. It's organized around this idea called spaces, where a space is a collaborative computing environment where you can run applications like a Google Docs-like document editor called Ngram. You have a crypto wallet that you can use to send to contacts in this group. There are voice chats, kind of like Discord, where you can pop up a group chat and talk to the people that are hanging out in this space. They have a shared cursor API, so you can get Figma-type shared cursors with everyone in the space on the fly in any application. You've got a persistent group chat with everyone there, and a whole suite of other applications that they're going to show you later, so I don't want to ruin their punchline, but it's kind of cool. All right. We should probably talk about blockchains because we're at consensus. Urbit is not a blockchain. It is not built on a blockchain. It kind of predates blockchains, or at least is a contemporary of when Bitcoin actually came out, right? But it is really complementary to blockchains, right? It comes from the same place of not wanting to have to rely on middlemen, on centralized authority for our information, where Bitcoin was concerned with finance, Urbit was concerned with general purpose compute. I should be able to have my own computer and run it myself, right? Now, chains, they're really good for very valuable global information that is public to everyone, right? Because everyone's basically accessing the same computer and writing to the same computer. That's really good for value. It's not really good for anything that is not valuable and that is high frequency write, because it's very expensive to achieve global consensus on the state of my chat history with my mother. I don't need that, okay? Urbit is really good for that kind of thing. I store my information. The only consensus I need is with the person I'm talking to. Okay? So when you pair those two things together, you get a lot of really great things. There's another company that's going to go on after Holium called Akbar. One of the things they've built is a poker application, which is kind of cool. Now, not only have they built a poker application, they built an entire layer 2 rollup on Urbit using Urbit's native language as a smart contract language and a whole execution engine for that. Right? And so they've been able to implement this poker game where all of us can run a poker application. We can talk directly to each other, share game state directly, and play with Goerli ETH for now. They're still on testnet, and with settlement happening on chain. Right? You can extend this to all kinds of games. Right? There's a lot of game state that does not need to be stored somewhere on a blockchain globally. It just needs to be available to people that are going to be interacting with, with one another. What's also kind of cool is that they built this on an Urbit application itself. They built a whole development suite that allows them to write Urbit's language. That's, write smart contracts in Urbit's language, test them, deploy them to their blockchain, all from within Urbit, in the same language that you use to write server-side peer-to-peer applications that talk directly to each other. Okay. Hawkwine will talk a little bit more about that a little later. Okay. Have you ever tried to use Urbit before? Like gone and installed it? A couple hands? Okay. Now, Urbit has a reputation of being hard to use. Now, you need an Urbit node to use just about all of this that I've shown so far. Okay. Now, if Urbit's hard to use because you've got to go and install some binary to command line and run it using your keys, right? This basically precludes anyone that is not a developer from using it. Okay, that's not good. That is not the case anymore. You can now get on Urbit by just clicking a link, entering an email, and a company will run this for you called Tlon. Right? I think there's about 34 slots remaining. You can install this right here. And you might think like, okay, well that probably defeats the whole point if now I'm just running this on someone else's server. But the key point, right, is that your Urbit can be exported into a single file, downloaded, and now run anywhere else. Okay, I don't have to stay on a hosting provider. I can now run this on like custom-built Urbit hardware by this company called Native Planet that's based here in Austin. This can run on your desktop. They're available for order. I have one at home running mine. You plug in that file that you got out of a hosting provider, and then up pops your entire ship running somewhere that you can access from anywhere on the internet if you have your credentials. You've got all your data, all your applications just as it was before. Okay. Now, you don't have to have an Urbit running to use everything there. There is also a company called Terrell that is building tools for creators. Right? You can now, right? You can publish content to the ClearWeb, pay wallet, basically have a self-hosted Substack with all of your followers, send emails to them, all from a server that you run and control. This is what Terrell focuses on. So you can use an Urbit like a normal server. You can serve content to the ClearWeb and build things like this. Right? But a lot of the good stuff happens when you run an Urbit yourself, which is now actually fairly straightforward. All right. Okay. So that's a bunch of stuff that's going on in the ecosystem that I think that underscores a lot of the points behind what you can do with the technology. Let's take a look at the ecosystem at a high level, just a few things to cover. For one, this is our Network Explorer. This is the growth of about the last 6 months. For a very long time, Urbit wasn't really growing at all. It was just people that were enthusiasts that were able to run an Urbit ship themselves. About 2 months ago, hosting started opening up. The network's grown about 50% in the space of those couple of months. And this is not purely due to Tlon, with that hosting service I showed you earlier. Holium has one, Akbar has one. There's now a bunch of different companies that have their own mechanisms for bringing people onto Urbit to host them for you. All of them allow you to exit and run it yourself should you want to, right? But you can get started fairly easily. We have a few developers. Okay, Urbit's been around for a long time. We've recently begun really ramping the ability for developers to use this thing. You couldn't actually distribute software until about the beginning of 2022. So this is still a fairly new capability for the system, and in the month, the year of 2022, and now going into this year, we've seen pretty tremendous developer growth. Breaking these down a little bit, there's about 90 monthly active developers, around about 700 total that we know of, which puts Urbit in about the top 20 projects, at least according to Electric Capital's developer report. A big reason for this is because of the ecosystem popping off. There's now a bunch of companies that are using this to build real products. Together they've raised, I don't know exactly how much, I think in excess of 20, 25 million. And this is all over the space of the last year. If you want to get involved, if you want to learn how to develop with Urbit, you can take one of our courses. We have free instructor-led courses by a guy named Neil Davis. He's a former computer science professor at the University of Illinois. He really knows his stuff. I can't recommend him highly enough. And after that, you should probably grab a grant. Like a lot of people here, we have a grants program. About half of all the full-time developers on Urbit, I think a little more than that now, have gone through our grants program, which is largely due to the fact that it's highly mentor-oriented. No one does a grant alone. Everyone does a grant in conjunction with someone else in the community that is well ingrained within the Urbit ecosystem and can kind of show them the ropes. So you can find this on our website and get into it. That is all I have. So I think I have some time for questions, if anyone has any. Thanks.
How do you solve the common problems with like the peer-to-peer applications?
Oh, there we go.
How do you solve like the common problems with peer-to-peer applications that we've seen in the past around scaling, like for example a chat room with hundreds of thousands of users that are trying to communicate peer-to-peer, and also privacy. You don't want everyone in the chat room to know your IP address, things like that.
Yeah, it's a good question. I don't know that we solve all the problems, right? Like, you can't really, if I break those down, scaling is one. The way that, say, groups works, if I have, in the groups application that Tlon builds that's, decentralized Discord-esque, you typically have one group host that hosts the group. That's the person that a lot of communication goes through. It's a hub and spoke model. So when I send a message in the group, I send it to the group host who broadcasts it out to everyone else. Everyone in the group stores in a complete copy of all of the group data. So you could switch hosts. Like someone else could take over the group and have all of the data that was in there. This isn't actually implemented now, but the data is basically duplicated around every single ship. So everyone has, that's how you store all of this. There have been things implemented that are not like that, where everyone is talking peer-to-peer. That's where you tend to run into a lot of these scaling problems. We do have some novel approaches in the works for allowing broadcast to work better and content distribution to be distributed more effectively. A big one of those is actually shipping May 9th that allows software to be distributed much more efficiently. But that's a little beyond the scope of me. I would probably defer to someone a little more technical than myself. As for everyone knowing my IP, Urbit doesn't use IPs. All the networking is happening over its own network called AIMS. You can't hide your identity from someone. If I'm communicating with you, if you're some other Urbit ID, imagine you're PalDev, like, we have to share the fact that your identity is who I'm talking to. There have been people that have implemented ring signatures in Urbit applications. There's a sample application on the developer site where you build a ring signature-based chat app. If you're not familiar with ring signatures, the idea is you can have a group of people that all have a signature together. I'm a little fuzzy on the details, but it basically allows you to communicate such that you can verify that a given message was signed by someone in the set, but you can't tell who it was. Right? And so that's a pretty tractable thing to build. Someone taking that concept and using it more fully would be pretty interesting. No one has done that yet, but they totally could, and there is a whole library for utilizing it. Does that roughly answer the question?
Yeah. I guess I don't understand how the communication operates in your system without just never seen that.
Yeah.
Like with IPFS, it has the same problem.
Yeah, it's like, how does the communication work without privacy issues?
You have an IPFS ID.
Yeah.
Yeah, like you have an IPFS ID, just like what you're talking about with an Urbit ID, your IPFS client ID. But if anyone on the IPFS network is watching things, they can tell where you are and what files you're hosting very easily. So I don't know. I mean, to me, this is the number one problem that these peer-to-peer internet solutions have never taken off, is because they haven't solved the kind of privacy and scaling problems. So I'm kind of surprised that it's not a priority.
I mean, if a solution is actually peer-to-peer, then there isn't any way to snoop on the connection happening. And that is true in Urbit. If I talk to you, there is no one else that is privy to that conversation or knows that the communication is happening. Right now, there is a question of how do I find a path to you somewhere in the world, right, of NAT traversal, right? I've got my ship running somewhere, you've got your ship running somewhere. How do we find each other? That's actually what Urbit's address space hierarchy is for. Stars provide packet routing. Galaxies provide packet routing above that. The idea is if I don't know how to contact you, to basically punch a hole through your NAT along the lines of, say, tail scale, right? I would escalate that to my star. If I can't figure out, I'd escalate to a galaxy, which is bound to a root DNS node under the Urbit.org domain. So at the top level, it's DNS, right? And now we can figure out how to find a path to you. And so there's a relay between figuring out, okay, I need a way to first establish connection to you, and after that point happens, all of our communications are peer-to-peer, and packets no longer move through any other connection. Does that make sense?
Yeah, got it.
Cool.
Also, I was wondering, like, how would you implement like a social media feed, like a Twitter feed, where you just need to aggregate tons of data from people that might not be in your network already?
Yeah, so this is the problem of discovery. Like, how do you discover things on a peer-to-peer network? And that's just a fundamentally hard thing. There is a newer Urbit startup called Portal that has built kind of a global feed by what they built is a curator model where someone can host, can be a known source of information, right? And that's effectively what you rely on, is something resembling centralized source, except it's implemented in such a way that anyone can be one of those, and then you can select which of those providers you want. And so you have shelling points for people to connect with one another. So Portal is like a generalized discovery mechanism where anyone can become a curator. They can publish groups, they can publish content, links, things like that. Other people can connect to them and find all of their recommendations, right? And those can form networks that allow discoverability to be eased. Gossip networks are another thing on Urbit. There's an app called Rumors that lets people anonymously post into it based on the friends of your friends using pals. So you end up with anonymous communications and just a wall of stuff from whoever you know and your friends know. So there are solutions to this. You're never going to get something like a Twitter unless everyone reads from the same place, in which case you've just recreated a centralized service, which you could. But it's not really the point. Discovery remains just a hard problem. And there's no reason you couldn't use something like a blockchain for that as well. Like, that is another good thing that blockchains provide.
Thanks a lot.
Yeah.
Yeah, thanks. Just quickly, I think you might have mentioned it, but if you're downloading the application, obviously it has to be in some kind of safe space on that server. What's the application written in? What's the scope of the app? And what's to stop, malicious code in that? Or do we just run this thing in a Docker, for a better word, and limit it that way?
Yeah. Yeah, so the current security model of Urbit is it's pretty primitive. It's based on Windows XP. Everything is root. It's not great. The way the application model is, code is packaged up into what is called a desk. Desks are managed by the file system called Clay. Applications are run in the application vein. It's like kernel modules called Gall. And they're kept segregated, and they have a limited ability to communicate with the underlying operating system. So the operating system protects itself from applications. There aren't yet protections between applications in user space. Actually, at the end of this month, we're going to be releasing user space permissions, which allows applications to request what kinds of access to different APIs that they need in other desks in order to provide security at that level. As far as like whether or not the code is malicious, there is no way to know unless you've gone and audited it, which you can do. One of the things I expect to happen is that most software will be distributed on stars. Stars are much more valuable. They're limited. There's only 65,000 of them. They tend to sell for a good deal more than planets. And so the idea is if I download a piece of malicious software from a star, then I don't trust that star anymore, and I'm going to tell everyone not to trust that star, and now that star has just tanked the value of its address space because it's gained a bad reputation. So you can leverage stars and galaxies. Galaxies are even rare. There's only 255 of them, as trust anchors, right? Who, because of their value and their rarity, are incentivized to not engage in malicious behavior. And so you can gauge the level of security based on where you're getting something from. Cool. And I got to wrap up. So thank you all. Welcome, Trent.